Good morning, everyone. Today, I will be presenting my work so far on my thesis entitled The First Japanese-Built Western-Style Ships, How Model Makers Have Shaped Our View of Late 16th and Early 17th Century Merchant Vessels. Before I get started, I would like to thank my advisor, Professor Harris, my reader, Professor Golden, and Ms. Prescott, the library director. I would also like to thank Shigemi Shaw, Shino Suzuki, Carlos Infantes Will, Dr. Larry Ferreira, and my family in Japan for providing me with many of the sources used for my research. So at the outset of this thesis, my initial objective was to analyze the effect of globalization on engineering through the study of the first Japanese-built Western-style ships. I thought this would be interesting because the Edo period in Japan was very isolationist, and the Japanese only had fleeting interactions with the Europeans. While I expected the availability of information to become an issue for my thesis, I did not expect this to become the subject of my thesis. And the primary sources were so few that the information plans and models of the Japanese-built vessels were based almost entirely on inferences made by historians using European vessels. So this led me to my new objective: to establish how much is known and the accuracy of what has been inferred about the first Japanese-built Western-style ships. So this thesis has kind of been a process of peeking behind the covers and unraveling many of the sources that have been really dominating our understanding of merchant ship from the late 16th and early 17th centuries. So today, I will discuss a brief historical context for this thesis, the first Japanese-built Western-style ships, and the models and replicas of these vessels. I will then summarize my conclusions and make some recommendations for future work. Japanese history can be broken up into simplified periods. The Sengoku period was when Japan was disunified due to constant civil war and social upheaval, and shipbuilding tradition at this time was mainly in military vessels and river boats. It was the Edo period when the Tokugawa shogunate unified the country and turned it into a peaceful society. There were also the first attempts at international diplomacy during this time, but Japan became increasingly isolated as it became more disillusioned with the Christians. They built some ocean-going vessels, and some historians even speculate that they could have been a naval power had they not further shut their doors. And the Meiji Era is what some of you may remember from US history. This is when Commodore Matthew Perry knocked on the doors and ended Japan's isolationism. And on the right is a picture of a scary black ship, as the Japanese called it. So Japan was rapidly brought into the steam age after this point, as shown in the woodblock print. And we're taught that they adopted all of these Western ideas and became an emergent world power. And I think this framework is very helpful for understanding Japanese history, but it does gloss over the fact that the Japanese were aware of some Western technologies that can help us better understand life during the Edo period. So yeah, the focus of this thesis will be the Edo period. While Japan was isolated, the Europeans were exploring, and they competed to find new trade routes to many places around the world. The Europeans arrived in Japan in the following order. The Catholics, the Portuguese, and the Spanish arrived first. But after the Protestants arrived, the Japanese leadership preferred them, and the Dutch and the English helped exile the Catholics, until later only the Dutch were allowed in Japan. Because of this world environment that I described, European vessels were designed for long-distance exploration and trade. The steep competition and political tension also encouraged shipbuilders to build larger ships to carry as much artillery and as much cargo as possible. So some notable features include the keel and vertical frame construction for longitudinal strength, and the fact that they divided sails to increase sail area, but keep ease of operations. In contrast, on the right is the Japanese wasen. Since the Japanese had no reason to go abroad, these were relatively small vessels. They were flat-bottomed with shell-poured structure since it was only focused on transfer strength, and they only had one sail. Moving on, William Adams was the first Westerner to actually share shipbuilding techniques with the Japanese. He was the first Englishman in Japan, and he arrived on a Dutch vessel in 1600. Historian Koichi Fujita actually considers him a catalyst just like Matthew Perry. William Adams built 2 ships, and research on his ships has been done in part due to Adams's popularity in pop culture as one of the first Western samurai. He's in many school textbooks and historical dramas of Japan, and he was also the inspiration for Gulliver's Travels and James Clavell's Shogun, which is shown on the right. He's also the main character of the video game Neo. It's possible, too, that this pop cultural perception of the vessels is doing a disservice to our technical understanding of them, and I will go into that a little bit more later. Some more Western-style ships were built by the Japanese for the Spanish. In 1612, San Sebastian was built, but foundered a mile offshore. And in 1613, San Juan Bautista was built in only 45 days and sent on multiple voyages to New Spain. The figure on the right shows a painting which is believed to have San Juan Bautista in the background, and this is a closer view of that vessel. Some of these techniques trickle down to other Japanese shipbuilding. On the left is a merchant vessel of the time, which has a Chinese-style junk rig, but also European-style square sails and lateen sails. In the center, Atake Maru was built in Ito, which is also where Adams built his ships, and it has a Western-style hull. On the right, Sankoku Maru was a Japanese attempt to copy a model of a ship that the Dutch gifted the Japanese, but this ship ran aground, and I thought it was quite funny that one of the Dutch sailors at the time wrote, "The Japanese should not busy themselves with trying to copy something strange, for they do not know how to handle it." And after this, the Japanese essentially jumped ahead to the steam age. Now I'm going to go into the models of the vessels. Not much is known about the vessels, so it's important to investigate how the models were developed with such little information. I first looked at the purpose of the research, because this affects the funding and the time allocated towards accuracy. I then looked at the credentials of the researchers. Specifically, were they naval architects or were they historians? Third, I looked at the validity of the sources. Were these observations made at the time, or were they written retroactively? And were they measured or were they estimated? Fourth, I looked at the method of reconstruction. Model makers use nautical dictionaries or contemporary sources or archaeological data or statistics to fill in many gaps in understanding. And the question is, what's best? Fifth, I looked at the accuracy of the construction process. Some elements had to be edited for ease of construction and safety, but this also affects the accuracy of the models. Time period also colors the accuracy of the models. So I considered such factors such as the absence of formal naval architectural principles at this time. Naval architecture really only just started existing as a more scientific discipline, and the graphic on the right was one of the very first attempts to mathematically break down a ship's hull, but it was more an explanation of what people did and not a rule that anyone followed. Second, I considered the lack of standardization of units. Units still depended on region at this point. Third, I considered the inconsistency in tonnage calculations. A ton could be measured by hoops and gauges, which are stand-ins for literal barrels or tons, or there are many different equations that attempted to capture the capacity of a hull, but they were not always accurate. Finally, I looked at changes in historical knowledge. As additional knowledge on history comes to light, these models can make continuous improvements. The following are some models based on the paintings I showed earlier. Left is Anjin Maru, and it's meant to be symbolic of Adams's ships. It was made for the Williams Adams Festival in Ito, but I consider it only a vague idea of his ships and can't really be looked at as an accurate representation. On the right is a model of a red seal ship made for the National Museum of Japanese History, and it's only based on a couple of paintings with no real consideration for seakeeping or naval architectural principles or sailmaking. So I think this is a prime example of models made in the historian perspective as opposed to the naval architect perspective. The purpose of these models was to educate and entertain, but they were not particularly meant to be accurate. The next model is of San Buenaventura, which is a 120-ton vessel built by Adams that I mentioned earlier. I actually saw this model when I visited Japan and learned that it is actually just a copy of a model of Susan Constant, which was one of the original Jamestown vessels. Susan Constant was chosen because it was equal to what we know of the tonnage of San Buenaventura and launched in 1605. Naval architect Brian Lavery developed this model using archaeological information of similar vessels and using first principles from various contemporary documents. Some recent theories have begun to question this choice of model and a lot about Adams, including his influence and his construction methods. We know that Adams wrote the ship was built exactly the way they were already built in our country, but we don't know if the person he sent this letter to was English or Dutch. So while we believe that his ships could have been built in the English style with the keel first method, it could have also been built in the Dutch style with the shell first method, And in general, Dutch ships would have been lighter and less heavily armed. San Juan Bautista was a replica built in 1993 for a park in Japan. I'm mainly going to talk about the development of its principal dimensions here, but the shipyard had also never developed or built a wooden vessel before, so I think there are also challenges and inaccuracies that need to be considered in the construction process. First, there are two concrete sources about San Juan Bautista. Date Teizan Jike Kiroku is the official history of the Date family and the lords of the Sendai domain. It lists the length, height, width, and heights of the masts of the vessel. Louis Sotelo also mentioned in a letter that the vessel was 500 tons, but it is unknown if this value was measured. So while we have dimensions, we still have to interpret them. And during the 1600s, units were not standardized. The modern conversion is that 1 ken is 1.82 meters, where 1 ken is the Japanese traditional unit, but that wasn't always the case. 1 ken is defined by a kyoma, where a kyoma is a pillar space or a tatami space in Japanese traditional architecture. Luckily, the Otemon Gate of Sendai Castle was built around the same time and place, and its ruins had a pillar space of 1.97 meters. So this was used for conversion. The dimensions still required more interpretation because length, width, and height can mean a lot of things when we're talking about ships. So the team making the replica contacted Dr. Naonosuke Takarada, who compiled a database of about 200 galleons and drew about 150 graphs of different trends in ship particulars so that he could find the dimensions necessary to corroborate Sotelo's tonnage using an English equation from the period that was a function of keel length, breadth, and depth in the hold. Here is one such graph he created. The x-axis is the year of construction, and the y-axis is a length divided by length over keel, which is the length of the flat part on the bottom of the vessel. Takarada concluded that the given length was LBP, so he needed to convert to keel length to calculate tonnage. He assumed Adams learned shipbuilding in the 1590s, so he then used a ratio of 1.36 to find keel length. And assuming depth is half the width, this produces a tonnage of about 539, and with a depth of 5 meters, this gives a tonnage about 498, which is near Sotelo's number. But this graph also includes vessels well outside of his supposed range and size, and includes military vessels and vessels from other countries. So the accuracy of the database is questionable. Using the same principle, he also interpreted the dimensions given for the mast. He concluded that height was actually height of the foremast, and foremast height was actually the mizzen height, but excluding the topmast, because this is the only way to make the values make any sense with the ratios. And still, this ratio that he obtained suggests a mast type from the 1560s, which is suspicious, but Takarada laments that he ran out of time. In order to better understand inconsistency in tonnage calculations, I decided to take the dimensions myself and see how likely Takarada's interpretation was. Using one of Takarada's preferred equations, I obtained a value of 540 tons. But using a Spanish calculation at the same time, which is equally likely since it was a Spanish vessel, I obtained a value of 360 tons. So this change in tonnage would drastically change the ratios and principal dimensions and could drastically change the size of the replica. There are theories, for example, that the current replicas of Columbus's vessels are double the size that they should be. So there is a lot of variability in tonnage calculation. In conclusion, historians and naval architects play a large role in our perception of historical vessels, especially when you realize that the data that is prioritized really shapes the vessels. In general, more modern historians have found the interpretations of Adams's vessels to also be representative of a greater Westernization of world history, and they are especially inclined to do this due to his popularity in international media. Every step of the model-making process introduces additional uncertainty. And in this case, a model is better treated as an impression of the historical vessel as opposed to an accurate replica. Finally, I think it's important to remember that a model is one of many interpretations of the available information. Some recommendations for future work include creating a new database of ships from the late 16th and early 17th centuries to see if Takarada's ratios of principal dimensions are in fact accurate. I think someone could also go a little further than my sensitivity analysis and use my historical research to develop new models of the vessels. It might also be interesting to study models of vessels from a different time period to compare how much knowledge is known and how much time period affects accuracy. In a more general sense, I think more historical research on how Asian shipbuilding developed in comparison to Western shipbuilding, since there's so little information on it, could be interesting. I also think that there is a place for theses that recognize just how much history and the humanities in general and engineering are intertwined. Thank you. I will now pass it off to Lissandro, who will be presenting his thesis. Please leave all questions at the end.